In this episode, we start with public key infrastructure, PKI, which is the trust system behind many secure digital interactions you use every day. The name can sound complicated, but the basic purpose is not out of reach. PKI helps people, devices, websites, applications, and systems trust each other when they are communicating across networks that may not be trustworthy by themselves. It supports encryption, authentication, and digital signatures, which means it can help protect information, prove identity, and show that something has not been changed. When you visit a secure website, install trusted software, connect to a corporate service, or verify that a message came from the expected source, PKI may be part of the background trust. You do not need to master every cryptographic detail right away. You need to understand the role PKI plays and why trust depends on protecting the right pieces. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. The first idea to hold on to is that PKI is built around key pairs. A key pair has a public key and a private key. The public key can be shared with others. The private key must be protected and kept secret. These two keys are mathematically related, but they do different jobs. Something connected to one key can be verified or processed using the other key in specific ways. That relationship is what makes public key cryptography useful for secure communication and trust. You can share the public key widely without giving away the private key. That is different from a shared secret, where both sides need the same secret value. With PKI, the public part can be known, while the private part remains protected. This split is one of the reasons modern digital trust can work at large scale. A public key is called public because it is meant to be shared. That does not mean it is unimportant or careless. It means the security model expects other people or systems to have it. A website can share a public key so visitors can establish a secure connection. A person can share a public key so others can verify a digital signature. A system can share a public key so another system can encrypt something that only the private key holder should be able to open. The public key is like a safe deposit slot that others can use, while the private key is the protected key that opens what was placed inside. That comparison is not perfect, but it helps you remember the direction. The public key can be distributed. The private key must remain controlled. The private key is the sensitive part of the pair, and protecting it is critical. If someone steals or copies a private key, they may be able to impersonate the owner, decrypt protected information, or create signatures that appear trustworthy. That is why private keys are often protected with strong access controls, encryption, secure storage, hardware protection, and careful handling procedures. A private key should not be casually emailed, copied into random folders, shared between people, or stored where unauthorized users can reach it. When a private key is compromised, the trust connected to that key can collapse. You can think of the private key as the thing that proves control. If the wrong person controls it, the system may believe the wrong person is trusted. That is why private key protection is not a small detail. It is central to the whole model. Encryption is one of the major uses of PKI, but it helps to understand what kind of problem it solves. Imagine someone wants to send information across a network where other people might be able to observe traffic. The sender needs a way to protect the information so only the intended receiver can read it. With public key cryptography, the sender can use the receiver's public key in the protection process, and the receiver uses the matching private key to access what was protected. This allows secure communication even when the two sides did not start with a shared secret. In real systems, public key cryptography is often used to help establish secure session keys, and faster symmetric encryption protects the larger conversation after that. You do not need to know every step yet. The main point is that PKI helps strangers begin secure communication in a safer way. Authentication is another major use. Authentication is about proving that an identity is really the identity it claims to be. On the web, you want to know that the site you reached is actually the site you intended to visit, not an imposter pretending to be it. In a company environment, a device or service may need to prove that it is a trusted system before another system accepts the connection. PKI supports this by connecting public keys to identities through certificates and trust relationships. A certificate can help say that this public key belongs to this identity. Without that connection, you might have a public key, but you would not know who it really belongs to. That is an important distinction. A key by itself is just a key. Trust comes from being able to connect that key to the right identity. Digital signatures are another place where PKI becomes very useful. A digital signature can help prove that a message, document, software package, or transaction is connected to a specific private key and has not been changed since it was signed. If the data changes after signing, the signature should no longer validate. That supports integrity because it helps show whether the content stayed the same. It can also support non-repudiation because the signature connects an action or item to the private key holder. You should not think of a digital signature as simply a typed name at the end of a message. It is a cryptographic process that helps create evidence. The strength of that evidence depends on the private key being protected and the identity behind the key being trustworthy. If the private key is not protected, the signature loses much of its meaning. Trust chains are how PKI avoids asking you to personally know every website, user, device, or service in advance. A trust chain connects an end certificate to one or more trusted authorities. Your device or browser already trusts certain root authorities. Those trusted roots can help validate other certificates through a chain of trust. When the chain is valid, your system has a reason to trust that the public key belongs to the identity named in the certificate. This is a bit like trusting an identification document because it was issued by an authority you already trust. You do not personally know every person who presents an identity card, but you may trust the issuing authority and the process behind it. PKI uses a similar trust idea, but in a digital and cryptographic way. A root of trust is the starting point for a trust chain. If the root is trusted and each link in the chain is valid, then the certificate at the end can be trusted for its intended purpose. If the root is not trusted, or if a link in the chain is broken, the trust decision can fail. This is why your browser may warn you when a certificate cannot be validated. The browser is not only checking whether encryption is possible, it is checking whether the identity and trust relationship makes sense. If a certificate is expired, issued by an untrusted authority, used for the wrong name, or connected to a broken chain, the system may warn you because trust cannot be confirmed. For security, that warning matters. Encryption without verified identity can still leave you talking securely to the wrong party. Certificates are the objects that help bind a public key to an identity. A certificate usually includes information about the identity, the public key, the issuing authority, the time period when it is valid, and what the certificate is allowed to be used for. You will study certificates more deeply in the next topic, but you need the foundation here because certificates are one of the main ways PKI makes public keys trustworthy. If anyone could simply claim that a public key belonged to a bank, a government service, or a company application, attackers could impersonate important systems. Certificates help reduce that risk by giving systems a way to verify the claim. The certificate does not make the private key safe by itself. It helps others know which public key belongs to which identity. One thing that can confuse you at first is the difference between encryption and signing. Both can involve public and private keys, but they are not the same goal. Encryption focuses on confidentiality. It helps keep information private from people who should not read it. Signing focuses on integrity, authentication, and sometimes non-repudiation. It helps show who was connected to the data and whether the data changed. You may see both used together. For example, a secure communication process may need to protect the privacy of the conversation and also confirm the identity of the server. Software may be signed so you can verify where it came from and whether it was altered. Keeping the purposes separate in your mind will help you answer questions more clearly. Ask whether the scenario is mainly about secrecy, proof of identity, proof of change, or accountability. PKI also depends on lifecycle management. Keys and certificates are not created once and forgotten forever. They need to be generated, issued, stored, used, renewed, replaced, revoked, and eventually retired. A certificate has a validity period, which means it is not meant to be trusted indefinitely. A private key may need replacement if it is exposed, if it becomes too old, or if the organization changes its security requirements. Revocation matters when a certificate should no longer be trusted before its normal expiration date. This could happen if a private key is compromised, if a certificate was issued incorrectly, or if the identity should no longer have that certificate. The trust system only works well when there are processes to manage these changes. Without lifecycle management, old trust can become dangerous trust. You should also understand that PKI does not remove the need for good security habits. It gives you powerful ways to protect communication, prove identity, and verify integrity, but it still depends on correct implementation and careful management. A strong certificate does not help if the private key is stolen. A trusted chain does not help if users ignore serious warnings. Encryption does not help if sensitive data is exposed after it is decrypted. Digital signatures do not help if signing keys are shared or poorly protected. This is an important pattern in security. A strong technology can still fail when the surrounding process is weak. When you study PKI, always think about both sides, the cryptographic idea and the operational responsibility. Trust is not automatic. It has to be built and maintained. For the exam, you want to recognize what problem PKI is solving in a scenario. If the question is about protecting a connection between systems that do not already share a secret, public key methods may be involved. If the question is about proving that a website is really the site it claims to be, certificates and trust chains may be involved. If the question is about proving that software was not changed after the vendor released it, digital signatures may be involved. If the question is about a stolen private key, the risk is serious because an attacker may impersonate, decrypt, or sign depending on how that key was used. Do not let the terminology distract you. Keep returning to the purpose. Public keys can be shared. Private keys must be protected. Trust depends on the identity behind the key being verified. The conclusion is that PKI is a foundation for digital trust. It uses public and private key pairs so systems can protect communication, verify identity, and support digital signatures. The public key can be shared, while the private key must be guarded carefully because control of that private key carries real trust. Certificates help connect public keys to identities, and trust chains help your system decide whether that connection should be accepted. When PKI works well, you may barely notice it because secure connections, trusted sites, signed software, and verified identities feel normal. When it fails, the result can be impersonation, exposed data, broken trust, or warnings that should not be ignored. As you continue, remember the central idea: PKI is not just about keys. It is about building a system where digital trust can be checked instead of guessed.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.